put mass down there. So, yeah, the table is the way it is because of the electrons, but since the guy didn't believe in electrons, he based it off of chemical reactivity. But since chemical reactivity is based off of electrons, roundabout way, it is based off of electrons. But again, it was not built based off of electrons. It was built off of their chemical reactivity. Energy levels, 7. How does that relate to the periodic table?
7. One for each row.
It has 7 rows. Sublevels, 7. And SPD, 9. Then there are 7 of them. Even though we don't use GHRI, we only use the first 4, they still exist. So how is it that they exist if they don't get used, really?
When an element gets super excited, it's extra.
Those positions around the atom are there, and when an element gets excited, its electrons can hop up to those spots, but it doesn't want to stay there. So they exist, but there isn't an atom with so many electrons that those things would be filled in what would be considered the atom's ground state, which would mean they're as close to the nucleus as possible. They only hop up there when they get all jacked up. How many electrons fit in an orbital? Dose. Sublevels found in the second energy level? S and P. And why is it S and P?
S is in all of them.
S is in all of them, right? And it's energy level 2, right? So since it's energy level 2, it's got its number of sublevels. And so that's why there are 7 sublevels, because there's a energy level 7, so then there must be 7 different sublevels within energy level 7. Electrons that fit into 4. So since it's energy level 4, there's an S, P, D, and F sublevel to fill, right?
Yes.
And the S can have 2, and the P can have 6, and the D can have 10. D can have 10, and the F can have 14. And so if I add all those guys up, what do you get?
36, right? 32. I did my math wrong. Dang it.
6 and 14 is 20, and 10 is 30, and 2 is 32.
Was I writing down?
Okay. Write this out. Alright, so what do we got here? 1s2 and 2s2 and 2p3. And can you give me 2 reasons how you know that's the correct electron configuration?
It has the 7 electrons.
First dot has 7 electrons. Nitrogen has 7 electrons, so we can add that 2, 2, and 3 gives us 7. Okay. And the other ray? Block. Yep. Yeah, you can. Second row, P block, third column in. Yep. Should hit that spot. Okay, S. So what do we have for the sulfur? We've got 1s2, 2s2, 2p6, 3s2, and 3p4. Same situation with that. You can add those electrons up and you'll get to 16, so that'll be sulfur. Or you can go to the third row, the P block, and the fourth column over, and you'll find yourself with sulfur. Okay. And iron. So I'm gonna be lazy. 6, and then 4s2, and then 3d6. And again, you add all those up, you get to iron's atomic number, and you'll find in the third, it's actually the fourth row, and the D block, it's the sixth column over, but those D's are offset by a number. Okay. Hund's rule, what do we have for that one?
That electrons fill empty orbitals in the same sublevel before combining electrons in the same orbital.
That sounds great. Empty sublevels. I'm sorry, fill empty orbitals in the same sublevel before doubling up orbitals. Okay. And the Pauli exclusion principle?
Electrons have a spin. And those in the same orbital have spin opposite.
Yep. So if you've got two electrons in the same orbital, they must be spinning in the opposite direction. Do you guys know what a PET scan is? Positron emission. The positron emission uses this Pauli exclusion principle to flip the electron around inside the orbital, and it stays flipped for a second and then flops back, and that's how you get a resolution within tissue inside of a person. I don't think anything other than people have been PET scanned.
So they force these little.
They force these little electrons to
spin the
be,
same direction?
yeah, just for an instance, and then they flip back around. It's like exciting them without making them leave their orbital. And they're flipped over, they kind of freak out, and they flip back and they release some energy. So you put energy in them to get them to flip and with a positron, and then they flip back to where they were and they release energy. And so the energy that they give is detected by a piece of equipment, and depending on what the tissue is, it'll give different different types of energy get put off.
Used for cancer, right? They use a lot to screen for cancer.
It can be used for anything where the tissue, adjoining tissues, or this maybe say a muscle, one particular, all the muscle and all of this tissue should be the same. And if there's something different about the tissue, it could be cancer, or it could be a tear, a muscle tear, then it's going to show up differently. It works similarly to the way that MRI works. It just differentiates between tissue, different tissues, and the same tissue that's in a different condition.
It's a lot more expensive than MRI.
It's a lot more expensive than MRI, but the price will come down now that people are using it. Same thing with MRI. Those things used to be cost prohibitive, right? And they're still pretty expensive, but nothing like they used to be. Heisenberg uncertainties principle?
That's where, like, we went to take a picture that the energy of the light would bounce electrons around, moving them before the picture was taken.
I'm not getting that. Nope. There we go. this is what it actually says, that you cannot know the position and the momentum of a subatomic particle simultaneously. But in reality, really what it means is every time you look at it or do anything to it, then you change it. And we talked about that with taking somebody's temperature, didn't we? If I put a thermometer inside your body, does the thermometer reduce your temperature?
It does.
It does. Does it matter? The amount of energy that you lost to the thermometer was so insignificant relative to your size, then it basically does not change your temperature. But to an atom, it would change the atom's temperature so dramatically that the atom would be moved.
Is that the same thing when you talked about like taking a picture or taking a
Yep,
picture?
exactly. Shorthand, why the last noble gas?
They're the most stable.
Okay, sure, it's a stable, alright, I like that, stable electron build, filled sublevels, titanium, so Ti 76, and then 4s2, 2, and 3d2. Is it 2? Yeah, 3d2.
Noble gas.
Oh, it only wants the noble gas. Oh. Well, geez, why did I do that? Bracket AR bracket. There we go. Alright, so energy level diagram for yttrium. I don't think I can draw this with a mouse, but I'm gonna try, just kind of for the fun of it. So this is energy, and I'll have a line, and then a line, and then 3 lines, and then a line, and then 3 lines. That really should be all the same size. And then a line, and then 5, and then 1, and then I don't think this is gonna fit. 3, and then 1, and then 1, 2, 3, 4, 5. Yeah, that looks terrible. So 1s, 2s, 2p, 3s, 3p, p, 4s, 3d. Oh, I didn't need that. Delete that out of there. 4p, 5s, and then I'll put it over here. 4d. Okay. And what am I going to do with this? 1 up, 1 down, 1 up, 1 down, 1 up, 1 up, 1 up, 1 down, 1 down, 1 down, 1 up, 1 down, up, 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 down, 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 up, down, up, 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 down, down, up, up. This is painful. Down. Oh, gosh. This is miserable. I need to get this pen fixed. And then up and down, and then one up. I don't care what your table says, it really needs to go in this direction. We read the table from left to right, and so you do put the 2 electrons into the 5D, sorry, the 5s, before you put the 1 electron into the 4D. I know your table says 41, 5s2, but it should be the other direction. Yeah.
Can we go back whenever we're done with this to the first question?
Yeah. Does anybody have any questions about this?
Move it down.
Move it
Yes,
slowly.
down.
Oh,
Sorry, I just ran out of space.
So what were you saying? You were saying the 5s fulfilled is for the 4D?
Yeah, when you're looking at the periodic table, you hit the 5s block before you hit the 4D block. So you put those 2 electrons in first, and then you add the electron to the 4D, because that's what the electrons actually do. Anthony, what was your question?
Back on one,
Yeah.
you said it was in order of increasing mass,
Yeah.
proton mass, because with the neutrons having all those different isotopes, you could have,
You actually do a couple of spots on the table, even with, it doesn't, like right now, if you look at it, the mass isn't in order.
you know, it looks like borium is less than hassium, but
There are a couple spots where the isotopes cause that to be the case, but at the time when the table was created, he put them in order of their increasing masses.